You guys have all worked with parabolas in the past. You guys have all graphed parabolas. You guys graphed them. Come on, guys. You guys graphed them when they look like this. Y equals ax squared plus bx plus c. You graphed them when they were written up as trinomials. All right. When you graphed them, you guys talked about the axis of symmetry. You found the vertex, and then you would go ahead and plot out some symmetric twins. Now, all of that still holds true, but what's going to change now is that our parabolas are going to have two different, or actually, they're going to go 4 different directions. We know about moving parabolas upward and downward. That was this case here. Y equals something ax squared. It went up like a cup if a was positive, and it went down like a frown if a was negative. All right. So we knew how to work with these before. Up like a cup, down like a frown. What's going to happen, though, is that we're going to change the way that we write about parabolas. We're going to write them for up like a cup or down like a frown, like the following. We're going to say y equals 4px squared. Oh, sorry. I wrote this backward again. X squared, excuse me, because that's the parabolas going up and down. So x squared equals 4py. And here's what all of these bits and pieces mean. If the p value is greater than 0, it's going to be up like a cup. If the p value is less than 0, it's going to be down like a frown. Excuse me. Now this p value is something different that we have not discussed about. Instead of having the axis of symmetry and the vertex and all that kind of fun stuff, what we're going to look at here is we're going to write things up a little bit differently. We still have, well, in the first few of these sections before, I think it's 10.6, everything that we do right now is going to have a vertex at the origin.
Yes.
So our vertex is always going to be at 0, 0 for these next few sections. We will shift everything, but we're going to talk about the basics first. Now, what I want to look at here is a regular, boring parabola that's up like a cup. We all agree, kind of looks like that.
Boring.
Boring is right. The curve being up like a cup meant that that value of a that we've learned before with the trinomials was positive. Now we're just labeling it up a little bit different. We're calling this value p is going to be that. Yes, sir? Correct. P was 0, then you would have a line at x equals 0. Okay. What we're looking at now is that we're going to label out some new parts. One of the parts we're going to talk about is called the focus. The focus is always inside the parabola. The parabola is always closing in on the focus, whether it's up, down, and in a minute here, right or left. It always is opening towards the focus. It's what it's looking at. Right? Kind of this, it's, for lack of a better way of using the definition, that's right. It's what it's focusing in on. We talk about focus, the foci, and what we're defined here in a second, multiple focuses. We use this stuff with mirrors, light reflection, refraction, things like that. Cameras, yeah, obviously. Duh, you're focusing something. So you use this, and eventually there's actually a problem in your homework that talks about a solar-powered hot dog cooker. We might just make this.
No.
Yeah.
But, yeah, let's do it.
We might, if we have time. I think we might have a little bit of time where we can actually create and make our own solar-powered hot dog machines. Be kind of cool. So anyway, this focus is always some given value from the vertex. To go along with the focus, there's another value, and that's called the directrix. directrix, oops, the directrix is always perpendicular to the axis of symmetry of a parabola. So if my axis of symmetry for an up like a cup parabola is always x equals a number, the directrix will have an equation of y equals a number. These two values, these two distances, will always be the same. If the focus is 2 spots above the vertex, the directrix would be 2 spots below. The directrix is always behind the vertex. Think of it as the counterbalance. Okay, think of it as like a counterbalance. Yes, sir?
What gives the distance from the focus? Is it within the equation, or is it?
Yeah, I'm getting that here in a second. The value p. The focus for an up like a cup or a down like a frown for an x squared is always going to be, well, if you look at it, the vertex is at 0, 0, 0. It's looking upwards at it. This value here, is this going to be 0y or y 0?
0y.
0y. We call this 0p. That value of p will allow us to figure out the focus. The directrix then, notice the directrix is a horizontal line because the axis of symmetry is vertical. What does every single horizontal line start with? X or y?
You said it.
The directrix,
Wait, why does it start with 1?
y equals.
Oh.
Every horizontal line is always y equals. Now, if my focus is here, the directrix would be below it. So it's the opposite of p. And this is going to work. Let me see if I can move this. Whether it is up or down. What happens here if my focus is at 0, negative p, the directrix would be at positive p, above it. It just rotates itself around.
So we should take notes on the computer.
What's that?
We should take notes on the computer, and then I could just like flip that and copy it. It's like which one it is, so we can try.
Do you have a tablet? All right.
I was at a smart board.
Yeah, like yeah, like we
A
should like
mini-
a touch.
A little mini
screen.
smartboard? Yeah. So here's what's going to happen.
I like a tablet.
When we work with these problems, we're going to do some rough sketches, plotting, and labeling stuff out. Let's look at the other version of it. The y squared. Now, the y squared equaling 4px just means it's opening right or left. A y squared parabola opens right or left. Right comes in. So if the p-value in this case is positive, that means it's opening to the right. If the p-value is negative, it's opening to the left. Just means it's looking at the positive numbers and moving and looking at the negative numbers. My focus now, well, if I draw this, if I'm going to the right, here's my focus, here's my directrix. Will my directrix be an x equal a number or a y equal a number? It's going to be an x equals a number. My focus, oops, it's P0 because it's on, since my, what do you call it, the vertex is at 0, 0. When I move it over, I'm at P at 0. The directrix then, oops, will be at x equals the opposite. And basically what's happening between the relationship between the focus, the curve, and the directrix is that any point on the curve is equidistant to both the focus and the directrix. Okay. And that's how you're able to, I hate using the same word, focus a light beam and move it towards something else. Archimedes' mirror, they tried that on Mythbusters. Basically what they were using here. The lenses of the mirrors try to all focus into one single curved lens to resend the light beam. All right? Laser beams for security systems, same idea. It's just not cool if you say it like that.
That's not
Parabolic satellite dishes. They're curved in because the LNB is a certain distance away from it. It's imaging it as it's pointing in the signal from space. It hits the parabola at a certain spot to hit the LNB. You know what an LNB is, right? Yeah. It's that thing that sticks out of the satellite dish. This kind of looks like a satellite dish a little bit. If you come out here, there's that one value, that one piece that sticks out looking inward at it. Like that. That's called an LNB. And I know too much about stupid things. Sorry. So what's going to happen here is that we're going to be able to graph these things with relative ease by just finding our focus, directrix, and one set of ordered pairs. And we'll be able to use our calculators to do this. Notice, there's no trigonometry here. Why is there no trigonometry? Because trigonometry is chapter 13. This is chapter 10. You haven't learned it yet. We've gone back in time. We've just gone 88 miles an hour in a DeLorean. Okay? Yes. Cuban circle. Yes, we're part of the Cuban circle. So let me give you guys a little bit of graph paper, and I want to walk through how we do this. Grab 2 sheets of this. One for the notes and one for the homework tonight. That's fine. I figured. And let me show you guys how this works. You should be pleasantly surprised. It's pretty simple.
Richard, how many do you have? Or if we have like...
That's fine.
Just take it.
All right.
I don't have to.
So right now we all have x equals negative 1/6 y squared. Guys, when I set this up, if I look at it, you can tell right away which direction this is going to go. It's a y squared parabola, which means it's got to go left or right. It's a negative y squared, so which way is it going? It's opening towards the left. Is everybody okay with that? So when you first do these problems and you're going to graph them, what I want you to do is, it's going to go like that. Yes, sir?
Don't you subtract by 12?
Yeah. I'm used to like...
Or you add it, and then that way the y squared is isolated, like up there.
You divide by
And then
1.
We're getting there. You're on the right track. You have to divide. We're not adding or subtracting here. It's 1/6 times. Okay? But you're on the right track. It's scary. Now, if you look at this problem, does everybody agree that's got to go towards the left? Every one of these problems over the course of the next few days, everything's going to be centered at the origin. So I know I can put that there. I know it's got to be going that direction. After I do that, the next thing I'm going to do is write down the generic formula for y squared parabolas. Y squared equals 4p times x. And this is alluding to what Leaf was just talking about. He said, let's get y squared by itself. How do I undo multiplying by negative 1/6?
Times.
Multiply it by negative 6. Multiply by the reciprocal. Everybody okay with that?
Yeah.
Yep.
So if I multiply by the reciprocal, I get y squared is negative 6x. All I did was just flip-flop the x squared, the y squared on the other side. Everybody okay with that? Now, I can identify and isolate what the value of p is going to be. Notice, these two equations are similar. 4px, negative 6x. That means that the negative 6 is playing the role of 4p. So you set them equal to each other. And that gives you p-value of negative 3 over 2. Okay.
Oh, I just took the 4 out of negative 6 and just did 4 times negative 2x. Right.
Yeah, set them up like that. So now I know that the p-value is negative 3 over 2. This is a y-squared parabola. It's opening towards the left, which now means that I know where my focus is going to be. My focus is going to be at 0, comma p. So it's at 0. Oop. If you want. Sorry, I wrote this at, it's supposed to be at p0. Sorry. Negative. Flip-flop it there. So it's at p, comma 0, because it's a y squared. The p-value is the x. So, negative 3, 2, and 0. There's my focus. Negative 1.5. The directrix is then on the other side. The directrix will be at, well, if the directrix for a y-squared parabola is x equals enough, x equals the opposite of p. My p-value is negative 3 over 2. This will be x equals 3 over 2. Again, just draw my little dotted line. So now I've got my vertex, 0, 0. These will all be at 0, 0. My focus I found by setting the 4p equal to the negative 6. The directrix was the opposite of the p-value. The last bit is to now go to my calculator to figure out an ordered pair that works. So here's what we've got. We have the following equation. Y squared equals negative 6x. In order to get that into the calculator, it has to be y equals. So I square root it. So I'm going to get y equals, well, in this case, whenever you take a square root over an equal sign, what do you have to do? Plus or minus. So I have plus or minus the square root of negative 6x. Now here's what happens. When I go to my calculator, and I'm going to put in y equals the square root of negative 6 over x, do I have to put in both the positive and the negative value? No, because they're symmetrical. I don't need to worry about that. So if I just type in y equals square root of negative 6x and hit my graph, I should get the top half of the curve. Everybody okay with that?
Yeah.
Now, how am I going to find an ordered pair that's clean?
Table.
Go to your table. And why do I have all of those errors at the positive values?
Negative 6, comma 6.
Because it's to the left.
Because you can't take the square root of a negative number.
I can take the square root of a negative number. So I'm just going to scroll and look for something that might work out cleanly.
Let's see.
At negative 6, I get 6. Everybody see that on their calculator? Did everybody not get that on their calculator? Yay. So that means at negative 6, it's 6. And it's also going to be at negative 6. Remember, these guys are symmetrical about the axis of symmetry. In this case, is y equals 0. So now I know how wide my curve is. That's all we got to do. Yes, sir.
For the, why do you have to figure out,
The order pairs?
like, no, you did the, you said that the curve was gonna go to left.
I knew the curve was going to go left because the p-value, it was negative. Do you see
have
how?
to, like, figure that, can you just wait until you figure out what
Well,
it is?
You're going to be able to tell that it's a negative because it's going to have a negative in it. And if you notice that it's a y squared, it means it's going to the left. If it was an x squared, it means it was moving downward.
But could you just wait until you did the y squared equals -6?
You can, if you'd like. But again, the reason that I'm putting that right off the bat is that way when I get going into the problem a little bit further, I know if I made a mistake. Because identifying direction is always the easiest. Yes, sir?
Is there a plus or minus button in the calculator?
No. Just do one of them and
Okay.
get the symmetric twin. Yes, sir?
So what is the point of finding the focus in the directrix? It looks like it did nothing for us.
The focus and the directrix, what happens here is that any point on the curve is going to be equidistant between here and here. These values are always going to be the same. Okay?
So what
Bless
should
you.
we use that for?
Again, it's mainly dealing with light, working with light beams and stuff like that. Sound waves as they bounce into a parabolic catcher. I don't know what they're called, but they use stuff like that. Camera lenses. What happens here is that if this focus point is further away from the vertex, you're narrowing in your band. You're focusing in on something. So if you wanted to actually focus on an object, you're dialing in the image. You're narrowing it in. If you wanted to get a big image, your focal point is farther away. It's like you're zooming. You're zooming in at a point. You're constricting the curve to make it a more precise
So we're
view.
just using it to know how
For
narrow
right now,
it is?
yes.
We
Yeah.
won't actually have to use it?
Eventually,
Alright.
we're just learning about the basics.
Alright.
Yes, sir.
Alex and I were thinking, like, this could be a really cool, like, the whole beam of light thing could be really cool album cover for, like, a rock and roll band.
You know, somebody should come up with an idea about that, like a prism.
Exactly.
That'd be pretty dark.
Exactly, when, like, the whole spectrum and stuff.
Mhm.
I'm thinking Pink Floyd or something like
That
that.
would be cool.
Yeah.
Some Roy G. Biv going.
Yep.
That's fine.
I think we lost him.
Let's try another one here.
Yeah, that's the album cover.
Wow. You didn't know this?
I thought it was a t-shirt.
Oh, dear Lord.
Of course it's a t-shirt.
Oh, dear Lord. Paul,
So what?
Paul, you have one. Paul,
-3.
Paul, your homework assignment tonight, go on YouTube, spend 43 minutes, and press play. That's your homework assignment. Don't do this. Your homework assignment is to listen to that album. If you've never heard that before, I'm sad to have you as a student.
I'll take that.
You can play it in class. You can force them to listen to it in class.
No. Let's try this again. One more of these, and then we're going to go on to the tough part of this assignment, which is really not that tough.
Murph, can I guess?
Hold on. What direction is this going to go, guys?
Left.
Yeah,
No,
left.
right, up,
Right.
down.
What?
Down.
It's a
No,
y
left,
squared.
Left, still left.
Left.
Still left. Murph, it's still left.
Left.
I said left first, then you tried to change.
Up, down, no, wait, it's right forward. It's down.
Up, down, left, right, start, stop, select. Yes.
Start, stop, select.
Now, in this case here, what is the value of p?
-3.
Everybody agree? P is -3. So, when I go to graph this, I know it's got to move to the left. So now when I go to walk off my p-value of -3, I know it's going to be, my focus will be at -3 and 0. I also now know that my directrix, the directrix is going to be at the opposite of -3. What's the opposite of -3? +3. and it's going to be x equals 3.
Why is it just a line? Why is it a point?
Remember, any point on the curve will always be equidistant to the focus and the directrix. So they're going to have a perpendicular distance that's always going to be the same, no matter where you're placing it on the curve. So now the last bit then is just to go to the calculator and type in y equals the square root of x, or square root of negative 12x. And go to your table. Again, as you're strolling through your table then, all you need is one set of ordered pairs that are clean, and I don't think that's right. I thought it was supposed to be negative 3 and 2. I might have said that.
Negative 3 and negative 6.
Oh, okay. You know what? I did a different problem. That's fine. So at negative 3 and what was it? And 6?
Yeah.
So I know my curve is going like this.
I bet you the next one we're doing H's and K's.
We'll do H's and K's with this later. What happens though is that we go through all the different conics to start with. We'll do parabolas today, circles, ellipses, hyperbolas, and then we shift them. And when we shift all those, it just gets messy. Yes, sir. What I did here was the square root of negative 12x. A lot of times people actually put in minus 12x. That's usually. Let me show you guys one other example, then I'll let you go. But not leave, but I'll let you get going. Now what do you do? Guys, I want you to write the equation that has the vertex at 0, 0, and the following directrix. So, by knowing where the directrix is, you will then be able to figure out what direction the curve is going to go. Therefore, you will be able to tell if it's an x squared or a y squared parabola. Remember, your directrix is always behind the vertex. So if I'm going to start this problem out, I'm going to draw a quick little grid. Know that my vertex is at 0, 0. And my directrix is at y equals 2. Y equals 2, is it a horizontal or a vertical line?
No, horizontal.
It's a horizontal line.
That means it's going down.
Horizontal.
So if my directrix is above the vertex, which direction is this opening? Downward. I know this is going to be opening downward, down like a frown. Is that making it an x squared or a y squared parabola?
X squared.
We know it's going to be an x squared parabola, so it's going to be y equals 4, or excuse me, x squared is 4py. I know it's going to follow that form. Now, if I'm at an x squared equals 4py, my directrix is y equals 2. That means that y equals the opposite of p is the directrix. What is the value of p? Negative 2. Good. Because my focus is here. Bless you. So if my p value is negative 2, all I have to do now is x squared equals 4 times negative 2 times y, otherwise known as x squared equals negative 8y. And I'm done. Again, what I'm doing here is I'm going to do a little rough sketch. I do not need to fill in all the blanks for the graph, but if I know where the directrix, or if I know where the focus is, I know which way my curve is opening, because it's going to open towards it. Because all of these problems will be centered at, or the vertex will be placed at the origin. We're not worried about H's and K's yet. We will get to that, and you're going to hate it. I'm sorry. Okay? Preguntas? Need you guys some prompts. Do those.
Oh, I didn't see that.
How many
It's
problems?
every other eye. It's like 14.
How many graphs do we use?
There's, I think there's only 4 graphs, 5 graphs maybe. The bulk of this assignment is basically identifying where the directrix is, where's the focus, what is the graph look like, and then can you write the equation if you're given a direct matrix, can you write the equation if you're given a focus. There's about 4 of each, 3 or 4 of those each style. It's really not frightening, okay? It's already up online. All of these PDF files are up already. I updated all of that, so you guys should be able to find it without a hassle, okay? Again, I'll start saving this here. There's no reason for you not to get half of this done in 8 minutes. I'm not lying.